Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1 and we are going to present about 3D texture mapping. So before we start our presentation, I would like to introduce myself. My name is Nurul Fatin Shuhada binti Muhammad Zaimi and my group members.
Tribenya.
My name is Aina Najah binti Anwar Rusdi.
So, uh, bef- so our first presentation will be conducted by Zulfikri.
What is 3D texture mapping? 3D texture mapping is the process of wrapping an image around a 3D model. It means that we have a texture and we map into the 3D model. Texture mapping usually apply to the surface of a shape or polygon. It can be bitmap image or procedural texture. Texture mapping can be used for defining specific detail like skin, hair, clothing, or anything else. Everything you see in the 3D objects for real is 3D texture mapping. This is the example of texture mapping. We have the object and we have a texture. When we combine, we have the earth. For this example, we have the map and we have the circle. We combine and we have the earth. For the second example, we have the part of our body. Before we map the real color, it look like gray, and when we have a 3D texture mapping, it look like realistic in our body. For our method, there's a method that are using in 3D texture mapping in order to apply mapping on some object. For first method is Mipmaps method. This method was created by Lance William in 1983. Mipmaps is the method where we put many things in a small place. In Latin, multum in parvo. It means that all the things put in a small place. In Mipmaps, we keep texture filter at multiple resolution. This method is used to figure out the closest level. This is an example of mid-map method. We can see the detail at the wing of the butterfly. For the second method is sum area table method. This method was created by Frank Crowe in 1984. This method is used to keep sum of everything below and to the left. In this method, we are using 4 table lookup. This method requires more memory, usually 2 to 4 times the original image. This means that this method is use a lot of memory. It get less blurry. This is the example of 4 lookup table. Next, I will pass the comparison that will conducted by Fatin Shuhada.
Okay, so in this section, we'll be discuss about the difference of the texture mapping concepts, types, and methods. So we have two concepts of texture mapping, which is non-parametric and parametric. As we can see here, the non-parametric, the texture size and orientation are fixed, and it gives cookies cutters effect, which is it have the same texture and lack of originality. As we can see here, it is in the same position and low quality because it does not change the texture based on the polygon. But in contrast to parametric, it uses the texture size and orientation that tied to the polygon, and it deforms the texture polygon into screen space. For parametric, a texture can modulate just about any parameters such as diffuse color, specular exponent, and many more. Okay, so next we go to comparison of texture mapping method. As Zul have discussed about the methods, so I will just give a big picture of the difference. So as we can see here, the most accurate method goes to sum area table. because it gives a less blurry textures compared to the others two. Okay, so here are the example of the pictures for each method. And as we can see here, the most blurry goes to map and the most realistic goes to sum area table compared to point sample. And then we go to the comparison of mapping types. We have three types for mapping, which is bump, normal, and displacement. For bump, we can see in the picture on the right top here, it creates an illusion of depth and texture and create a fake details. And then the normal, they have no additional resolution added and simulate details on surface. That's why it is the fastest between these types. And then for the displacement, it just like normal, but it create more realistic details. Okay, so here we can see the normal maps and bump maps. In the bump maps, we can see the details is more specific and it is kind of fake because it is too much. And then, okay, so we can see the difference between bump maps and displacement maps here, which is the bump maps adds a fine detail and displacement to the heavy lifting, which is we can see here the displacement maps is more realistic compared to the bump maps. Okay, so this is for the comparison. So I will pass to Aino Najwa.
Okay, for my part, I will talk about the example implementation for texture mapping. So, as Zul mentioned before, we all know that texture mapping consists of combination object and texture. For example, as you can see there, Coke tin also can apply texture mapping using textures on rectangular object and polygon, which is fairly straightforward. The texture applied to the curved surface and for the flat surface, the texture are applied to differentiate the bottom and top of the tin. So for the second example, mid mapping is one of the method for texture mapping. So mid mapping can be used to reduce aliasing effect that occur when texture are mapped to various size region in a scene. So mid map filtering modes also can improve the appearance of the scene. So next, for the first picture, for the teapot, the environment mapping are applied to the teapot, which is can be done using the sphere mapping or cube mapping. So for the second picture, before we can proceed to the environment mapping, we need to use texture coordinate first to apply the texture on the irregular surface using the OpenGL. So next, so for the, as you can see the picture below, it is the implementation of texture mapping to remove missing colors of the shoes. So texture mapping also can apply to add new texture to the part of the object that missing colors. As you can see at the slide, picture A and B show the process before the shoes added the new texture. While for the picture C, show that the shoes after the process of adding new texture to the shoes. So next, so for the last picture, as you can see above, we have picture A and picture B. So texture mapping also can be used for blending algorithm. For picture A, it shows the process for the shoes before and after the blending to the shoes. So the different texture can be used and blend and combine to the one object, which is the shoes. While for the picture B, texture mapping use blending algorithm to add the stickers and shadows to the texture of the mark. So the mark will look interesting. So I think that's all from me, and thank you from us.
Thank you.